Thank you very much. So a question for the audience here. If you're all familiar, anyone familiar with the term cloud native, please raise your hand. Well, keep it up, keep it up, keep it up, keep it up. If you were familiar with the term 5 years ago, keep your hand raised. More or less what I thought. Cloud native is a shiny new toy in our industry. It gets thrown around quite indiscriminately in terms of going to be the savior of all our problems in terms of service provider modernization. And certainly, probably, there's a lot that can be gained from cloud native. What we're going to do today is explore just to what extent that it can be used and what we really need to do to adapt it for a service provider type of architecture and framework. But let's see where we start. What is the goal that we're trying to achieve in terms of modernization? And what I submit to you, it's nothing short of revolutionizing the way that we deliver services. The bar has been definitely raised in terms of service delivery from the cloud. Customers that are getting cloud services expect them to be agile. They expect to be able to order services on demand, have them changed on demand, built up, torn down, etc. This is coming from the cloud. This is coming from over-the-top suppliers who are using the telecommunications network to deliver services. And this is certainly the kind of the goal that telecommunications service providers need to have and do have in terms of modernizing their infrastructure. So what kind of services are we talking about? Well, let's give a few examples. Dynamic VPNs. It sounds sort of trite, be able to set up the endpoints, be able to allocate the bandwidth. But let's give an example of how that can be used. Let's say you're a multinational company located in Berlin, and you want to have a large advertising campaign, and you have it down to 3 finalists. One's located in New York, one's located in London, one's located in Australia. And they're each going to have a chance to do a 20-minute pitch to your board of directors in terms of their best and final, in terms of what they're going to propose for their advertising campaign to you. So you have all these highly placed executives sitting in your boardroom in Berlin, and each one of these companies in different locations is going to get 20 minutes. You want a high bandwidth connection, you want it to be secure, you don't want it to go down. Today you can't do that. Or you can, but it will take you weeks to set up those kinds of connections. Really, yeah, you can do it broadband over the internet today, but you're not going to get the kind of quality that you need to do this really expensive advertising campaign that you want to pitch. You need to have higher bandwidth, secure connections. This is just one of the kinds of examples that people should be expecting to get in the future. What about modernizing your business services? It's not just about bandwidth and connectivity, but it's also the type of services that you can provide on top of that bandwidth and connectivity. And here we're talking all about the things that exist over layer 3. So whether it's firewalls, whether it's universal threat management systems, whether it's management of your WAN, even management of your internal LAN, these are the kinds of services that today we put under the umbrellas of technology such as virtual CPE, if you're coming from that space, or you're coming from the technologies of SD-WAN if you're coming from that space. But these are probably one of the few areas where we're actually starting to get a little bit more dynamism within the network today. So far, I've given you 2 examples in terms of telecommunication services. But really, if we want to sort of go up the value chain in our industry, it's more than just about the connectivity services themselves. It's being able to be a platform for value-added services. Here's one perfect example. The technology exists today. You can Google this stuff online in terms of being able to do remote surgery. The equipment exists in terms of laparoscopic surgery, that you'll make the cuts into the person's body, and then you'll do the probes and the cutting with that. And there's an operator station where a person, the surgeon, will sit there and play with the controls. Now, say you want to offer this as a service. Your surgeon's located in some city living in a fancy apartment, but once a week he offers services for people that don't have access to this kind of surgery, say in some more remote country of the world. We can put the equipment there, but we still need to be able to create the connection, which needs to be high bandwidth, it needs to be highly available, and it needs to be fixed latency. Again, this is something today, if we want to set this up with our networks today, takes weeks to do that. We should be going towards a world where we can provide these things very quickly, the same way we order services off the cloud. And then talking about the network as a platform, the next big thing that we're going to be able to achieve, and it's really on the horizon, and we see it today in a lot of forums. It's being really able to take advantage of the fact that service providers have a built-in advantage for providing high bandwidth, low latency services at the network edge, what I call the intelligent edge. These are for services such as for augmented reality, virtual reality, smart cities, smart cars, really where things like latency really do matter a lot. And the service providers, because they're highly distributed, close to the end customers, have a built-in advantage. And what they need to be able to do for these types of services is to combine connectivity services with computing services and deliver those to the kind of companies that will provide value added on top of that to serve those end users who have those particular requirements. So there's a very large realm of services that we should be aiming for in terms of revolutionizing services delivery. And this is important not just for the service providers, but throughout the chain of our industry, including the solution providers like ECI, because our future livelihoods and our future success all depend on making that happen. Besides the services themselves, when we talk about revolutionizing services, it's also being able to automate network operations. The services rely on operations, and we've seen a number of presentations today on that. Certainly, several of them preceding myself talked about that. And a lot of these times, these are represented by what I call the circle of life, in terms of going from planning, design, configuration, build, monitoring, provisioning, assurance. And we've broken this down into 5 segments over here. I think there's a number of versions of these things floating around. But what we're trying to achieve under this automated operations, or what's also being broadly called zero-touch management, is being able to speed up the infrastructure to deliver the services. The last part of the equation, in terms of what we're trying to achieve in the industry, is optimization of the underlying network itself. And this is one example here of a multi-layer optimization. If you take a look at the left-hand part of the diagram here, this is a router view of the network. It needs to make connections among routers, and you're showing these as logical links with the dotted lines. But it then passes those requirements off to the optical network to make the links. But the router network has no idea how these links are being made. Zero idea. On the other hand, you're the optical network. You get a number of connection requests coming from the IP layer, and you need to connect up this red point here to that red point here, etc. And you can do this through various means, using point-to-point links, using ROADMs, using OTN switching, and you provide the connections as needed. But you have no idea what services you're providing. As a result of that, you need to over-provision the network in case of failures. So the separation of concerns has some advantages, maybe in terms of simplifying the construction between your optical network and your IP network, but you're left with a non-optimized network overall because the left hand doesn't know what the right hand is doing and vice versa. When you go towards a view through a centralized control that looks at this big picture together, what you're able to do is achieve the same level of reliability, including restoration paths, because the hands are able to talk to each other. So you can do more with less. So again, another one of our goals towards modernization, including the services modernization, is getting the most efficient network to support that. So now we come back to our original question, the shiny new toy, cloud native. Can it serve to be the recipe for success for being able to revolutionize telecommunications services? I show cloud native here from a variety of aspects, really showing some of the more basic IaaS, PaaS, SaaS kind of layering that you see within the cloud. Some of the more cloud-native types of software development techniques based on microservices, based on containers. This is the general language of cloud-native. The question is, it has been used with great success in the cloud itself, in large centralized data centers. The question is, can it also be used by service providers to achieve their goals of revolutionizing services and modernizing their network? So I said yes and no. So why yes? From a purely applications point of view, I guess you can say, why not? All these tools are there. There's a lot of things that you can put off the shelf. There's architectures that are well documented. And so just applying techniques such as microservices, applying containers, being able to put together the kinds of applications quickly for things such as continuous delivery, being able to bring things to the marketplace more quickly, those are all available today. Really addressing what I show over here in terms of the sort of the DevOps cycle, primarily on the development side, you can start to use cloud-native techniques very, very quickly. Those tools are there. The more challenge becomes when you're looking at the deployment and the operations side of the house. And here, I'm saying no. There are things that you can't do so easily with cloud-native today because of the fact that you're deploying these applications over a large distributed network with different levels of scale from the edge to the core, different levels of technology running from layer 0 through layer 3, different levels of expectation in terms of robustness, all providing different types of challenges towards really building applications using the more standard cloud-native techniques, which were really designed for a centralized, much more homogeneous data center architecture. So what do we need to do? Let's address each of these points. I address a couple of them together in the next few slides. How do we bridge the gap? So what's the gap and what do we need to do to bridge it? So the first gap that I identify is the fact that when we're building services, particularly advanced services, we're combining two sets of telecommunications functions. In the past, it was just connectivity, connect point A to point B, specify a certain degree of bandwidth. What we need to do today on top of that is add virtualization. On top of that, we need to address the challenge of multi-layer optimization that I talked about earlier. So what is the way that we're going to address this particular challenge? And what I'm saying is what we need is strong orchestration. If you go back a few years, really the whole realm of SDN and NFV technologies were quite orthogonal to each other. They were brought together within the same conferences, but you had your SDN tracks, you had your NFV tracks, and these worlds really didn't spend as much time intersecting. Today, and I'm very happy to see that, they're really beginning to come together in a variety of ways. But this is something which we need to deliver as an industry. We need to be able to address the entire communication stack of SDN, both from an underlay and overlay point of view. And we need to take a look at the NFV stack and how that gets addressed throughout the network in terms of pulling together the connectivity with the virtualization in terms of service chaining very quickly to deliver these agile advanced services. I think the number of approaches that have been discussed, maybe when you're coming from a sort of an OSS vendor, maybe when you're coming from points such as your Mano. I saw some nice parts of the presentation on the open source Mano, which is beginning to address certain elements of this problem. I don't think the full solution is there yet, and we're going to continue to see various solutions in the industry, but it's something which needs to be addressed. The next gap that I want to talk about is the fact that we have services with endpoints over multiple carriers. I gave you an example earlier about the person or the company in Berlin that needs to set up communications with New York, London, and Australia. Those poor sods in Australia need to get up in the middle of the night to deliver their presentation, but what could you do? But right now, a lot of the standards that we're talking about are really within particular service provider and particular technology domains. What we'd be able to need to do to solve this problem is have inter-service provider communications. And I'm going to suggest that one of the very strong initiatives in the industry that that we're very closely involved with at ECI ourselves is based on the MEF Lifecycle Services Orchestration, where they're developing a whole set of interfaces for inter-OSS and inter-BSS communication. And actually, just before the conference, they announced that a toolkit was available for the Sonata interface, which is one of the key interfaces for making this happen. Actually, at the MEF last year in Baltimore, we led a testbed project, which we got an award for, where we set up communications across the Atlantic with 3 carriers. And we're continuing this right now at ECI. We're working with PCCW Global, with Tata Communications, and with Telecom Italia Sparkle in terms of a fixed testbed sandbox to be able to test and continue exercising these interfaces towards making them a reality. And this is something which is really, we need strong commitment on the part of the industry to make this happen so we can all be successful. The final element of the gap that I want to address is the fact that we have a highly distributed network, particularly with intelligence at the network edge that I had mentioned before. And we have a network based on customer expectations for carrier-grade availability. And what I suggest is that the way that we need to address this is to take that middle layer that I talked about before within the cloud-native model or the PaaS and make that a carrier-grade PaaS. And I can easily say that this is a full session in and of itself. I can really just touch on some of the elements, what's required to make this a carrier-grade PaaS here today, but I maintain these are the main requirements for which a number of solutions can exist. For one, it needs to be scalable. The PaaS needs to support applications from the network edge, where you might have a sort of smaller sets of computing platforms, through the telco CO, through telco POPs, all the way into a service provider data center. On top of that, it needs to be robust. It needs to know the health of its applications, know about problems before they actually occur, be able to address those problems before they actually occur, to really get the kinds of 5 nines, or if not 6 nines, which I've begun to see talked about availability that people expect from the telecommunications network. It needs to be secure. I don't know, people are talking about security over here, but this is something which needs to be built into the PaaS because it's a resource layer which is available to many different people, and that needs to be one of the main features from day one, both in terms of people accessing the PaaS as well as the applications, of course, and it needs to support licensing. There could be lots of features within the PaaS itself, and it needs to make sure that people can only access what they're paying for. And then finally, it needs to be a workhorse. There's lots and lots of data coming from the network. And not all this data needs to make its way into the applications. The PaaS needs to support a whole set of resources to sort of pre-process this data so that it could be analyzed in a more efficient manner by the application sitting on top of it. So, in conclusion, the question that we raised at the beginning of the talk was cloud native, which we all agreed upon is the shiny new toy in this industry that we're beginning to become familiar with and using as the basis for a lot of our new architectures for delivering applications for revolutionizing telecommunications services can be based on that. But what I'm maintaining is that we need to go beyond just giving it lip service, and we need to build in extensions to make it a reality. And I've identified 3 over here. It needs to support strong orchestration between connectivity and virtualization. It needs to support advanced interfaces, that this isn't just effective within a particular service provider's domain, but that it can be used across service providers. And we need to take the platform as a service layer and really extend that to make that carrier grade. I'm happy to say that this is, at ECI, this isn't just a vision, this is something that we're actually doing. We're using this particular forum to start talking about our Elastic Services platform, which brings together both our set of transport products covering layer 0 through layer 3 and virtualization on top of that, with the kinds of cloud-native applications infrastructure to deliver the benefits that we've talked about before to revolutionize telecommunications services. So it supports a pure cloud-native architecture, a set of service applications and network applications covering SDN and NFV. It supports an ability for third-party applications to sit on top of that, and all built on top of a carrier-grade pass. And of course, you can access these benefits directly through our own Elastic Services Platform portal, as well as northbound interfaces into OSS BSS that it could be exercised as part of a larger ecosystem. We invite you to our booth to learn more about the Elastic Services Platform. And thank you very much.